Hey everybody, in this video we will be determining where a function is increasing and decreasing using derivative rules. So we're asked to consider this function f of x equals 2x cubed plus 3x squared plus 1. We need to find the intervals where that function is increasing or decreasing. So increasing and decreasing, that makes me think of slope, positive or negative slope. So let's take a derivative. We'll have that f prime of x is going to be equal to 6x squared plus 6x. That's just from the power rule. And to find when a function changes direction, that'll happen when the slope is 0. Say I have some function that looks like this. This is the point where the slope is 0. We can see that it's going from decreasing to increasing. So that's pretty much what we're doing here. So we will set our f prime equal to 0, and we want to solve for x. So we can factor out an x, and we'll just be left with 6x plus 1. Actually, let's factor out a 6x. That'll make it even easier. Still equal to 0. And this tells us, or this gives us two equations, 6x equals 0, and x plus 1 equals 0. And from that, we can deduce that x equals 0 is a critical point, and x equals negative 1 is a critical point. These are the points we want to test. We determine that the function f of x will change direction at these points. So the next step is to draw a sign chart. It may seem every now and then to be a little unnecessary, but I promise it's super helpful. Even like in future classes you'll take, like differential equations, I've had to make sign charts, so it's good to get used to it pretty quickly. Just draw the general line for that. What I'm going to do is I'm going to mark the critical points in red. 0, and we'll have negative 1. And I'll indicate that this is the x-axis. Up here, we're going to be talking about the sign of f prime. And then after that, we'll consider the behavior of f. All right, so what I like to do now is we have these three regions. We can plug in test points for each of those regions and determine whether it's going to be positive or negative sign of f prime. So let's just say we have a value of negative 2 over here. Now, the way I like to do it is when we have this factored form, these two factors, I just consider each of them individually and then determine if it's positive or negative, and I'll show you how that works. So when I plug in negative 2 for 6x, I get a negative. Actually, I'll just leave it without the circle for now, a negative. When I plug in negative 2 for the factor of x plus 1, I get negative 1, a negative number. That's also a negative. And a negative times a negative is a positive. Now let's consider a point, let's call it negative 1/2. Because it's between negative 2 and 0. Or sorry, between negative 1 and 0. So if I plug in negative 1/2 for 6x, I get a negative. But then negative 1/2 plus 1 is a positive 1/2. So that's a positive. And a negative times a positive gives us a negative. Finally, let's consider the point 1. 1 into 6x gives us positive 6, a positive. And then 1 into x plus 1 gives us 2, a positive. And a positive times a positive is a positive. So now we have those signs of f prime filled out. Now you consider the behavior of f. So If I have that the sign of f prime is positive, that means we're increasing. And then when I have a negative sign for f prime, it'd be decreasing. And same here, increasing because it's positive. All right, so we've pretty much done all the math for part A. Now we just need to really make sure we do a good job answering the question because it asks us to find the intervals on which f is increasing or decreasing. So what we'll want to say is f is increasing on, and we need to determine our like notation or interval. So starting all the way over here at negative infinity, so right here, it's increasing. So in negative infinity to -1, union with 0 to infinity, because I'm picking back up right here with that positive slope. And then we'll also say that we're decreasing on -1 to 0. That's right here, between -1 and 0. And you'll notice I use like the parentheses instead of brackets here. And that's pretty important for these questions. If we won't use brackets, because at this point, let's say -1 and 0, we've determined that the slope is 0. So it won't be increasing or decreasing. It'll be completely flat slope. So that's why we use those parentheses there, because it's not inclusive. All right, so that's part A answered. Very nice. Now we're asked to find the local max and min values of f. So we have our critical points. We know that those just intrinsically will be potential candidates for local maxes and mins. So let's plug those in. And also take note that it says local. That means we don't need to consider endpoints, which makes sense because we're not really given endpoints. We're not given an interval in this question. So we only need to consider those critical values you already found. And also, looking at our sign chart, we can already tell which point is going to be the local max and which will be the local min. So I'm going to start over here, and we know that we're increasing until we get to -1. Now we're told that we're decreasing, and then finally at 0, we're back to increasing. So based on this, we could say, we can already determine that our max will be at x equals -1, and our min will be at x equals 0. I'll just sketch that in real quick. This might not be exactly how the graph looks, but that's just the general form we need to know. This is x equals -1. This is x equals 0. And it tells us to be sure to actually find the values of the coordinates. So let's do that. So we know we'll have a local max at x equals -1. So f of -1. And notice I'm not using f prime, I'm using f because we want to just find the regular coordinates. This just comes from our function right here. 2 times -1 cubed. Please use parentheses when you're plugging in, especially when you deal with negatives. Otherwise, the roots might get a little wonky. Or not roots, I'm sorry, the exponents. The exponents might get a little wonky. All right, and this just evaluates to -2 plus 3 plus 1, which equals 2. So our max will be at -1, 2, because -1 is our x, 2 is our y. Now we can consider our local min, which we determine will occur at x equals 0. F of 0, pretty easy. This goes away, 1. So our local min will occur at the point 0, 1. All right, there we go. So a little summary for this learning target here. You need to find the intervals, so we take a derivative, set it equal to 0 to get our critical points. We do a sign chart. Given the zeros that we solve for here, which is -1 and 0, we test values between or beyond those intervals. So we chose -2, -1/2, and 1. We plug those into each individual factor, and we'll get like a negative or a positive for each of those factors. By factor, I mean this and this individually. And then if you multiply two odds together, you get an even. Multiply an even by an odd, you get an odd. And that will tell you the overall sign of f prime. And then a positive f prime means f is increasing, and a negative f prime means that f is decreasing. We want to make sure we really write out what f is doing, what it's increasing on, what it's decreasing on, and we'll be using parentheses, no brackets here. The next part, finding the local max and mins, we can determine that from our sign chart just by thinking I'm increasing, then I'm decreasing, and then I'm increasing again. Oh, that's not very good. Increasing, decreasing, then increasing again. And then if it asks us to, we'll be sure to find the x and y coordinates, which just means a point. Oh, didn't mean to erase there. Just means a point. All right, hope this helps.